Good day, everyone. Once again, welcome to our class in Math 051, Engineering Calculus 1. So this time we'll continue our review of functions. So this is now part 2 of our review of the topic functions. So last time we have discussed about finding the range and domain of the functions. And one of the examples was a function that contains a radical. Okay, so that was our last example in our part 1. So today we'll continue to solve uh, the domain of the functions using the principles that we have learned. So another example, we have here the given function and we're asked to find the domain of this function. So we have f of x, or function of x, is equal to 2 divided by x minus 4 plus 6 divided by 5 plus x. So to find the domain of this function, we have to uh, set the denominator. First denominator here, x minus 4 to 0, and also 5 plus x equal to 0. So to determine the value of x, that is not included because the value of x that can make the denominator equal to 0 will be excluded in the domain. Okay, so first we need to find the value of x that can make this denominator equal to 0. So we have uh, x minus 4 equal to 0. So here, if you transpose 4 to the other side, or if you add 4 both sides, so we get x equal to 4. So this is the value of x that can make the denominator x minus 4 equal to 0. So we have to exclude this in our domain. Okay, so the other one is 5 plus x. Okay, so we equate this to 0 and solve for x. So 5 plus x equal to 0. So to solve for x, we have to subtract both sides by 5, or you just transpose 5 to other side. So we'll get x equal to minus 5. Okay, so these are the value of x that can make the denominator equal to 0. So it will make the function undefined. Alright, so the answer here is that the domain of this function is x such that x is a real number and x is not equal to 4 and x not equal to negative 5. Or in another notation, how will you present this? So we have to draw the number line system. So on the right side we have the positive infinity, and on the left side we have the negative infinity. Okay, so assuming this is our 0, so assuming this is the 0 of the number line system, so we have 4, so 1, 2, 3, and we have 4. And then we have negative 5. Okay, this part here. That is on the left side of 0. So negative 1, we have negative 2, and negative 3, so negative 4, and we have negative 5 here. Okay, so these are the numbers that we should not include. So we have to divide this number line into intervals such as this. Alright, so we have here this part. So for this part here, okay, so we have this one interval. So how will we represent this in annotation like this? That is inside the parenthesis. So this is negative infinity, and we have minus 5. So minus 5 is excluded, so we have to use this symbol. So what symbol is this? Is it how do you call this symbol? And this one? Okay, so we use this if we have to indicate that this number is excluded and this number also excluded. Alright, so that is for this interval. And another interval is from here to there. Okay, so this is in notation, set notation, we can write this as minus 5. So minus 5 is excluded, and we have positive 4. Okay, and for this part here, so we have here 4 and positive infinity. Okay, so these are the intervals, and we know that the domain of this function is a real number, and x not equal to 4 and x not equal to minus 5. It means that all real numbers except 4 and negative 5. So we can say that the domain so above statement also is a domain, this one, or uh, or the domain so we have minus infinity or negative infinity and minus 5. So you listen carefully here because you will have some numbers to practice after a few slides. And we have another one, we have 5 negative. Okay, so this is negative, and we have 4. This is the ordered pairs, and the other one is 4 positive infinity. So plus infinity, okay, so we have to combine all of them. So we have to use this symbol, union. Okay. So the domain is the union of all these sets here. Okay. Negative infinity, negative 5, and negative 5 positive 4, and in union with positive 4 and positive infinity. Okay, so that's how to uh, write the domain in this notation. Any question? Next, another example is we are given here a function of x, which is equal to negative 4x squared minus 2x plus 7. So what do you think will be the domain of this function? So if you examine the given function, there is no value of the variable x that can make, when you plug into the function, that can make the denominator equal to 0 because there's no fraction here, and also there's no radical. So our answer here is, since the function has no denominator or square root, so there are no real numbers that when plugged into the function for x would cause the value of the function to yield something other than the real number. So therefore, the domain is x such as x a real number. Okay, so how will you represent that in another notation? So domain, so if you graph it, class, okay, so if you put them in the number line, so this would be what? So it means positive infinity, so negative infinity here. So it says that there's no real number or real numbers that when you plug into the function would yield something other than a real number. So therefore, so we have to consider all these interval, all the numbers within this interval. So the domain therefore is from negative infinity to positive infinity. Okay, so do you have any question? So I hope it's clear with you how to find the domain. No? If the function has no radical and no denominator, then our answer for the domain are all real numbers. X such that x is a real number, or in this notation, negative infinity to positive infinity, excluding of course the negative and positive infinity. So all numbers that belongs to this interval are considered the domain of this given function. Next, so in the next slide, you have the list here of few numbers for your exercises. So all you need to do is just find the domain of each function and use the concept that you have learned from part 1 of our review of functions, and also the examples that I have given you in this uh, part of our review. So you're given here four numbers: y equal to 3 over x plus 2, Okay, so surely uh, for the value of x, this makes 0. Okay, so you just indicate what's the domain. How will you write that domain? For b, you have y equal to square root of 2x plus 3. So how will you solve for the value of x such that the radicand would contain only a 0 or positive? So 2x plus 3 here should be greater than or equal to 0. Otherwise, it makes the radicand a negative, which yield an undefined result. Now for C, you have uh, so for C you have x minus 5 over x squared minus 9. So what's the value for x here? That can makes the denominator 0. Okay, so exclude that for your domain. And D equal to D, we have y equal to x squared minus 5x plus 7. Alright, so I think this is these are simple numbers for you to practice. And if you're confident that your answer for this part is uh, are correct, then there's no reason that you will fail in our quizzes or any exams. Okay, so let's continue. So we have here graph of a function. So the graph of a function is a set of all points in the plane that corresponds to the ordered pairs of that function. So to graph the function, here are the steps that we need to follow. First, we have to make a table for the values for x and f of x. And then after that, we choose values for x and then plug into the expression. Then compute. So we have to do the computation for f of x. And then once you have the values of x and f of x, then you are ready now to plot the resulting coordinate points on the xy plane. Then after that, you connect the points, so you will get the graph of the function. So those are the 5 basic steps to follow in graphing the function. Now we have next kind of function is called constant function. So what does it mean, constant function? A function of the form f of x equal to k, where k is any real number. The graph is a horizontal line that passes through the constant k. Okay, for example, or before the example, we have here another principle that the domain is the set of real number and the range is the set of or the set containing k. For example, if you're given f of x equal to 2, so you graph that. So f of x equal to 2. So this is the uh, f of x means the value of x equal to, sorry, the value of y, f of x equal to 2. So at this point, so this is 2, right? This is 1, 2, 3, 4, and so on and so forth. Okay, so we have here this line. So this is the function f of x equal to 2. So the domain, it says that the domain is the set of real number, and the range is the set containing k. Okay, so containing k. Then linear function. So what is linear function? Linear function is a function that is defined by f of x equal to m times x plus b, where m and b are constants and m must not be equal to 0. So it's a graph, or sorry, its graph is a line with slope m and y-intercept b. So the b here is called the y-intercept. So this is called y-intercept. So what does it mean, y-intercept? So what does it mean, class, when you say y-intercept? Okay, so from the illustration, oh, by the way, the domain is R and the range is R. So you have the same domain, real number, and the range is also real numbers. So for example, if you have f of x equal to 2x plus 6, so when you graph that, you will see this line. So in sketching a line or a graph which is a line, you need only 2 points. And to do that, you have to solve for the x and y intercept. So it means that when x equal to, this is the y intercept, the value for f of x when x equal to 0. Okay, so that is the value for y when x equal to 0. So this is the b. Okay, this is the y-intercept. Okay, and then when y is 0, or f of x when f of x equal to 0, so this is the value of our uh, x. When f of x equal to 0, then you get x here, which is equal to 3. So in other discussion, we call it normally as RA. Okay, so to graph the line, you just so you just let x. So first we let x equal to 0. So when x equal to 0, then you can solve for the y-intercept, which is the value of f of x. So when x equal to 0, so you have f of x. So what is the value of f of x? So this is equal to 6. Okay, so when x equal to 0, you have f of x equal to 6. In other words, that is the, so when x equal to 0 here, so you have 1, 2, 3, 4, 5, 6. So this is 6. So the coordinates of this point, okay, so this is still composed of x and y coordinates, or abscissa and ordinates. So uh, the coordinates of this point is 0 and 6. Okay, now if we let f of x equal to 0, if we let so now if we let f of x equal to 0, so what is our x? So we have the value of x equal to, so when f of x equal to 0, so you transpose, this is 0 on the left side, you transpose this 6 to the left side, then you solve for x, so you divide both sides by 2, which is the coefficient of 2x, then you will get x equal to minus 3. Okay, so x equal to minus 3. So therefore, the coordinates of this point here is minus 3. That is the value of x when f of x equal to 0, or f of x is equal to 0. Okay, so you have now 2 points. Okay, so you have these 2 points here, this point here, and that point. Okay, and then when you connect this point, then you will get this graph or this line. So you just connect these 2 points, and then you will have this line. Okay, so the domain of this function, so the domain is R, all real numbers, and the range is also R. How about this? So for this given function, you're asked to sketch the graph, and you're asked also to determine the domain and range. So we're given here the function 2x plus 4y equal to 8. So what's the domain now? What's the domain? Okay, so first we have to graph the function. This is a linear function. What we need is only 2 points. Now that is from Euclid's axiom that 2 points determine a line. In other words, when you have 2 points, you just connect them, then you will have a line. Okay, so how to find the 2 points? We have to solve for the intercepts, the y and the x intercepts. So in other words, you have to set x equal to 0. Okay, so solving for the x intercept, you have to set y equal to 0. So when when y is equal to 0, okay, so when y is equal to 0, so we got this 0 from the step of solving for the x-intercept. So when you speak of x-intercept, you set y equal to 0. Okay, so when y is equal to 0, then go back to the given function. So when this is 0, okay, so you have 2x plus 0 equals 8. So you have 2x equal to 8. So divided by both sides by 2. So you'll get x equal to 4. So that's why you have here 4. And you have the value for y 0. So ito yung 0 na to. Okay? So we use that 0. And yung 4 dito, yung result after you set the value for y to 0, and you have solved the value for x. Okay, any question? Then how about the other? So in other words, class, we have now the first point. So where is this 4, 0? Okay, so from our graph, from our coordinate system, so ito yung ano natin this is our y, which is equal to function of x. Meaning ang value sa y natin is dependent on the value of x. So we have y equal to f of x. And this is our x-axis. This is our x-axis. So in other words, we can plot this 4, 0. This is an ordered pair. So when y is 0, x equal to 4. So where is it? So it is in this point, right? It is at this point. Okay, and then now next is we have to solve for the y-intercept. So for the y-intercept, it means that you have to set x equal to 0. Alright? So for the y-intercept, you have to set, or you have to let x equal to 0, and you solve for the value of y. Alright? So go back to this equation or function. So for the y-intercept, you get this when x equal to 0. So ito yan. When x equal to 0, so what is the value of x? So when x equal to 0, what is the value of y? When x equal to 0, so 2 times 0, 0. So you have 4y equal to 8. Now solving for y, so divide both sides by 4. So 4y divided by 4 is 1. Then you have y left. So y equal to 8 divided by 4 equal to 2. So that's why you have here 2. Okay, so you have the other points 0, 2. So when x equal to 0, y is 2. So it means we are at this point. Okay, so that is the second point. Now we have 2 points, and connecting the 2 points, then you will have the straight line. So you just connect these 2 points, and you will have now the line. Okay, so that's our line. So what's now the domain and range? So the domain, therefore, is again, that is because from this equation there is no value for x that when you substitute, there's no value for x and y when you substitute or plug into this equation will make the in other words, there's no denominator and there is no radical. So all values of x and y will give you the domain. Okay, for the range, so ganun din for the range. So there's no value for y that can make the function undefined or can cause a division by 0 because there's no fraction here, and there's also no way that there's a negative inside the radical because there's no radical in this function. So the domain and the range are just the same, all real numbers. Or this is negative infinity to positive infinity, that is for the domain, and for the range, negative infinity and positive infinity. Okay, so I hope this is clear with you, class, and I hope you have recalled already how these functions work. And next is the quadratic function. So what is this quadratic function? So the general quadratic function is defined by this equation or expression. So f of x equal to ax squared plus bx plus c. Where a, b, and c are real numbers and a should not be equal to 0. Alright, so that's the condition. The graph of f, meaning the graph of this function, is a parabola that opens upward. If, so the condition here, if a is positive. Okay, so if a is positive, then the parabola opens upward. Now if the parabola opens downward, or if a is negative, then parabola opens downward. Alright, so just remember these two conditions. So this is very helpful information that help us determine whether the parabola opens upward or downward. So just remember that if the variable x is being squared, meaning there's an exponent that is even, that is 2, then we can say that this is either opens upward or downward. So that depends on the value of a. If A is positive, then we're sure that the parabola opens upward. If A is negative, then the parabola opens downward. Alright? Now the vertex is given by the point. This is the formula for the vertex. We have negative B over 2A and 4AC minus B squared over 4A. So it means that this is our first element of this ordered pair. That is the abscissa, and this is our ordinate. Alright? Now, what is this B and A? So it is given in this function. Alright, so this is your A here, that is the coefficient of x squared, and B is the coefficient of x, and the C is the constant. Alright, so whatever is the value of A and value of, whatever is the value of A and the value of B and the value of C, you just substitute to this formula for the vertex so that you can get the vertex. Because normally in this topic you're asked to graph the function. So the best way to graph is just to find the vertex and the value for, you need only 3 points. You have the vertex and at least 2 points of the parabola. Okay. Now quadratic function, the domain is the set of real number and the range is the interval. The range is the interval given by this. So this is our abscissa, and this is our ordinate, something that is approaching the infinity. So the range is expressed in terms of an interval. Okay, so you just calculate the value of this part here, and then you have that number, then you have on the right side infinity. Okay, so positive infinity. That is if A is positive. So remember, that is our range in interval form. If A is positive. Otherwise, if A is negative, so it reverses. So we have the infinity here on the left side, but negative, and the same thing here, right? We have 4AC minus B squared 4A. So it's very easy to graph the parabola, just knowing all this information together with this one. So you can easily graph for the parabola. Okay. Next, we have here an example. Sketch the graph of this parabola. Okay, so here for our solution, what is our A? So A is the coefficient of x squared. This is 1, so positive siya. So it means the parabola opens upward. Then our B is equal to 4. And we have C, which is equal to 5. Okay, so you have this information. Just plug into the formula, then you will be able to get the vertex. And since we know that the parabola opens up, then the in terms of range, then the range is on the right side is the positive infinity. On the left side, you have the calculations that you're going to do. Okay, so the answer, first you need to find the vertex. So how to find the vertex? We have to use the formula. We have B over 2A Then for the, this is for the abscissa, and for the ordinate, you have the formula 4ac minus b squared over 4a. Alright, then substituting the values, you'll get here negative 2, negative 9. This is an ordered pair, no, for our point, which is the vertex. Alright, so next you need to find the y-intercept. So what is y-intercept? That is the value of y when x equal to 0. So our equation here, this is our y, because our y is a function of x. Okay, ang y natin is a function of x. So y is a function of x. So y is a function of x equal to a function of x. So y, which is equal to f of x, then x is equal to 0 because you're solving for the y-intercept. So solving for y-intercept, then you have to set x equal to 0. And then substitute or plug in this value of x to the given function. Okay, from this given, then you will be able to solve for y. So in this case, we have solved y. Y is equal to negative 5. Alright. Now for the x-intercept, so to find the x-intercept, so you have to set y equal to 0. But y is equal to f of x, right? Y is a function of x. So you set the f of x, which is equal to y, equal to 0. And then you solve for the value of x. Okay, so when f of x equal to 0, you substitute it here. So 0, okay? And then you will form a quadratic equation, right? So we have 0 equal to x squared plus 4x minus 5. So you'll have the equation now, x squared, then plus 4x, then minus 5. And it's equated to 0. Sorry. Okay, so how will you solve for x? So this is a quadratic equation, so you need to, what? You have to factor, no? So need factoring. So you have x and x here. Factor of x squared, you have x. Then here we have negative 5. So what are the factors of negative 5? Since your middle term is positive 4x, so you just use positive 5 and negative 1. Okay? So therefore, the factors are x, now x plus 5. Okay, so one of the factors, x minus 5, sorry, x plus 5. And the other factor is x minus 1. Then equate this to 0. So in other words, you're just equating this. We have to we factor this one, then equate to 0. So therefore, you have x plus 5 equal to 0, and the other factor is x minus 1 equal to 0. So solving for x in each of these factor, so you have x here, you transpose 5 to the other side, so you have x equal to negative 5. Okay, and here you have x equal to positive 1. Okay, so that's it. We have x equal to minus 5, x equal to 1. Now to graph this, so how will you graph? So as mentioned, you need only 3 points in graphing the parabola. You need the vertex, you need points, you have the intercept. So in other words, by this y and x intercept, you will be able to get another 2 points. Okay, so I will erase this part so that we can draw on this part here. Eraser. Okay, so I will erase this. So that we can use this part for the graph. Okay, so this is our graph. So the vertex, we have the vertex here, 2, negative 2, negative 9. So where is that? So our abscissa is negative 2. So from the center, this is our 0, 0. This is the origin. Okay. Then from here, you start, you have first number is negative 2. So it means to the left. So you have to count 1, 2. So meaning here. Okay, so from here, you go down 9 units, 9 steps. So this is negative 9. It means that from this point here, you have to go down 9. And where is this? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is the vertex. So the coordinates of this vertex is negative 2 and negative 9. Or I'll just put it here down. So negative 2 and negative 9. Okay, so this is negative 9, sorry. To erase this, have to erase this also. Okay, so this is negative 9. Okay, much better. Okay, so this is the first point that we need. So you need the vertex, and then you have to find the intercept. So we have here the intercept when x equal to 0, y is negative 5. So where is it? When x equal to 0, y is negative 5. So x 0, y negative 5. So x is 0 is at the origin. Then y is negative 5. So you go down 5 times down. 1, 2, 3, 4, 5. So it means at this point here. Okay, so we have this point. So the coordinates of this is negative, sorry, this is 0. Okay, 0 and negative 5. So that's the this is the coordinate of the second point, because in graphing the parabola you need only 3 points. Okay, so for the next intercept, we have when y is equal to 0 or f of x equal to 0, then you we're able to solve for x equal to 5 and negative 1. So we already have negative 5 here for f of x. Sorry, it's not. Um, when x equal to minus 5, so we set here f of x, meaning when y is 0, x minus 5. Okay, so we have here. This is the point. So we have 2 points when y is 0 or when f of x equal to 0. We have x equal to minus 5 and we have x equal to 1. So when y is 0, we have 1 point here. So this is our, the coordinate of this point is x minus 5. Okay, so minus 5. And the y here is 0. Okay, so this is the other point. Actually, with this, you can already draw. No? We have 3 points, but you have another value for x. It might help also. When y is 0, or if of x is 0, x is 1. So where is this? X is 1. So this one, right? So for this, you have 4 points. So this is x equal to 1, and the y here is 0. Okay. So we know that in the steps, we have 5 steps in graphing the function. And the last step there is to connect the points. Alright? So connecting the points, you start from the vertex. Okay, so from the vertex, then passing to the points. Okay? Alright, and then you just extend. When it passes to the point, you then extend it. Extend something like this. Okay? And from the same vertex, you use the principle of symmetry. Because parabola symmetric lang yan sila, class. One side is symmetrical to the other side. So that's why you have this. Okay. So that's it. So now we're able to graph the function f of x equal to x squared plus 4x minus 5. So I mentioned a while ago that you need at least 3 points. But here, because of the result of our calculation, we have 2 values for x. So we can have 4 points. Okay, so that's it for this example. Now another example. So sketch the graph of this given function. You have f of x, x squared plus 2x plus 5. So we just do the same steps that we have done a while ago. First, you need to find the vertex. So using the formula, you get this vertex, minus 1 and 4 for the ordered pair. And then you have, for y-intercept, you need to assume value for x equal to 0 and solve for the value of f of x or equal to y. Okay, so we got y equal to 5. So y is equal to 5. Galing yan dito, class, ha? So again, y is equal lang to siya sa f of x. So in other words, you have to use the equation below for f of x. Okay? So y equal to f of x. So f of x natin is x squared plus 2x plus 5. So for the y-intercept, so you set x equal to 0. Okay? So setting x equal to 0, then substitute this x equal to 0 to the equation above here. So when x equal to 0, you'll be able to solve for y, which is equal to f of x, equal to 5. Now for the x-intercepts, you need to set the y value, which is equal to f of x. So y equal to f of x. So you set this to 0 and you solve for x. So set y equal to f of x equal to 0. And then using the equation above, so this equation here, using this, then you can solve for x. So again, this is a quadratic equation. So we'll see that we cannot find the, if you look at this, so the value for x is none. So what does it mean? Why it's none? Can we apply quadratic formula? So when we apply the quadratic formula, so the result is none. Ano yung quadratic formula? We have from, I think this is x. When you are solving for x, when you're solving for x, you have the formula x equal to minus b plus and minus the square root of b squared minus 4ac. Sorry, 4a. Let me erase this one. For AC, then all over 2a. Okay, so if you use this formula, so let's check now if the value of you have value of y here, so ang a natin dito, our a is equal to 1, then our b is 2, our c is 5. Okay, now if you substitute these values to this equation, ang b natin is 2, so 2 squared, that is 4, minus 4ac. So what will happen is that the value under this radical would be negative. Okay, so the value of x is undefined, so we cannot define the value for x. Any question? So that's the reason why it says here that for the when you find the x-intercept, so you assume value for y equal to f of x equal to 0, and then the answer there is none. Alright, any question? Do you understand, class? Okay, so that's the reason. So the reason why is it that when you solve for x here, the result is none because of this. So from the, we cannot factor the equation, so we try to solve it using the quadratic formula. This is the quadratic formula. Okay, this is a quadratic formula. Quadratic formula, QF. So using the quadratic formula, so when you substitute the value for ABC, so ang B natin is 2, so 2 squared equal to 4. Okay, so we have minus 4 times A, which is 1, so 4 times C, which is 5, 20. So 4 minus 20, so that is negative 16, square root of negative 16. So our radical here, our radicand is negative, so square root of negative, we know that that makes the function undefined. So therefore, we cannot determine the value for x because of that. So we have here none. Alright, so how will you graph this? Again, I will erase this for the space of the graph. I will erase this writings here to give us space. Okay, so to graph this, well, we know already the vertex. Then we have 1 point here. Okay, so this is our graph. We have the vertex, that is negative 1, 4. We have here negative 1. Okay, so this negative 1 here, from the origin, 0, 0. So you move negative 1, so on the left, so this is our negative 1. Then 4, you move 4 units up, 1, 2, 3, 4. So this is the vertex. Okay, so the coordinates of this vertex is negative 1, 4. Okay, negative 1, 4. This is the coordinate of the vertex. Now we have here 1 point. When we solve for the y-intercept, when x equal to 0, y is 5. X equal to 0, y is 5. So we have x 0, so 0, then you go up 5 steps. So 1, 2, 3, 4, 5. So we have at this point. Okay, so this is x 0, then y is 5. Okay, now if you can still remember from your analytic geometry, by the way, when you connect this point, these 2 points here, connect and then you just extend, no? Connect and then extend. So you have this graph. Then from the analytic geometry, we apply the concept of symmetry. Alright? Para makompleto natin yung graph. So it means that, so ito yung kalahati niya. Right? Then, parabola yan siya. So whatever is the graph on the other side, that will reflect on the other side also. Okay? So that's why even if you have only 2 points here, but using the concept of symmetry, you can still graph this function. Okay? So in our previous example, it's easier because you have 4 points. But here you have only 2 points. So if you don't know that concept of symmetry, then it's hard for you to graph this function. So perhaps if you don't know also the concept that if A is positive or negative, no, because it's either plus or minus. So in this case, our A is positive. So we know that, and then in this function, x is being squared. Okay, so we know that parabola opens up, either opens up or down. Then you just examine the sign of A. Okay, so for A positive, so parabola opens upward. Alright, and then for A, which is negative, so the parabola opens down. So this idea, class, could help you also draw or graph the function. So with this additional information. Alright? Kasi, pwede naman na, okay, you don't know where the parabola opens up or down. So, pwede rin kasi na ang drawing mo is something like this. Right? If you know only the concept of symmetry. Pwede rin, sabihin mo, by symmetry principle, I will do it like this. Which is wrong. Right? So, if you know the concept that if x is being squared, so parabola opens either up or down. Right? Now, to help you that, so kailangang matandaan nyo yan na pag x ang squared, then up or down lang yan siya. And then you determine the sign of A either plus or minus siya. But ano yung A is the coefficient of x squared. Okay, so in this case, so we know that the opening is in this direction, upward, not this one. Not this one is wrong. Alright, so I hope it's clear with you. Okay, so that's it for sketching for graph. We have two examples for parabola. Now another exercises. You have to sketch the graph of the following functions and also find the domain and range of the following functions. So just apply what you have just learned in the first part of our review of this function, and also uh, the principle that you have learned in the second part. Okay, so I'll end my lecture at this point, and see you again in the next video, continuation of this review of functions. Thank you very much and have a good day to all of us. Bye.